Going to determine the explicit formula for the geometric sequence given, and then the eighth term after finding the generic formula. So the first thing we need to note is the formula for a geometric sequence is given to us by AR to the n minus 1, and that's for any term. So I do know a couple of things. I do know that a sub 1 is equal to a to the r1 minus 1, which ends up being a itself, right? Because the ratio r to the 0 is 1, and so a sub 1 will always equal a. So this means since a sub 1 in our sequence is equal to 16, that this implies that a is equal to 16. Okay, so let me note that's one piece. The next piece would be to find, so this is the first part, is we found A. The second part would be to find the ratio R. So we do know that A sub n is equal to A R to the n minus 1. And if I plug in what A is from above, that's just going to be 16 to the R n minus 1. And again, the 16 comes from the first term in our sequence. Okay, so let's go ahead and use one of the terms they give us. So let's use a sub 2, which is equal to 96 over 17. Let's use this to determine R. And what this ends up being is just a little algebra problem, and then we can find a sub 8. Now, I understand that there are other methods that you can use, but in this case, I think this is a fixed method, and you can always depend on this method versus trying to see it just by looking at the terms. Okay, so if a sub n is equal to a times r to the n minus 1, and a sub 2 is equal to a to the r2 minus 1, then let's go ahead and translate this to the pieces of information that we know. So I do know that a sub 2 is 96 over 17, which is equal to a, which is given to be 16, and then to the r to the 2 minus 1, which is just 1, which is just r. So I can solve for r by just multiplying by the reciprocal of 16 or divide by 16. So it'll be 1/16 times 96 over 17. So if I do that, I get 6/17 is equal to r. Okay, so here is my other piece of my information. All right, I'm about to answer the first question. So the formula for a sub n now would be a r to the n minus 1. So a sub n is now equal to 16 to the ratio r, 6/17 to the n minus 1. And again, the 16 comes from the first term of the sequence. And the r comes from solving using one of the other terms. Okay. So now what's next to find is a sub 8. A sub 8 is going to equal 16 times 6 over 17 to the 8 minus 1. And again, looking at this closely, notice that the subscript on the a is actually the n on the exponent. So the n's have to match. And we can just see from over here in 1i that that was the case. And also when we used a sub 2, that was the case. So just be careful of those little tiny things. Okay, so if we wrote this or put it in the calculator, if we try to simplify, it would be 16, 6 to the 7th, which is 279,936 over 17 to the 7th, which is going to be 410,338,673. And then times 16 would become 4,478,976 all over 410,338,673. Now this is a little bit of a larger values for the numerator and denominator. So sometimes they just put in the decimal representation, which is 0.01.